So today we are going to discuss about the topic is Introduction to Deep Learning. So myself and Pranish, System Professor, Department of Computer Science, Sri Ramakrishna College of Arts and Sciences. So these are some of the contents today we are to discuss. First, the definition of artificial neural networks, inside in artificial neurons, perceptron and uses, multi-layer perceptions and feed-forward neural networks, activation functions, cost functions, and finally some of the application of neural networks. So before we move on to this artificial neural networks, first we know about what is the meaning of neural networks. So the neural network is a mathematical tool or design in which we are to based on studying some of the neurons, how the neuron will be working in the systematic approach. So coming to the artificial neural network, see what is an artificial neural network? It is a non-linear statistical data, either in the form of decision-making tools or model. So the main objective and used for artificial neural network is to solve the supervised and unsupervised machine learning problems. And the problem may be model, it may be either in the form of the relationship between input and output, or it should be find some of the pattern. The most of the neural network problem may be either in the form of simple or complex. So the overall we can define the of artificial neural networks. It is a statistical data model for solving the complex problem based on supervised and unsupervised learning problems. So inside an artificial neurons, what are the elements of what are the parts are needed to carry out some of the artificial neural networks? So in this picture, x1, x2, x3, x4, these are some of the inputs are passed through the respective layer to the weighted format. So the W1, W2, W3, W4, these are some of the weighted. So some of the inputs are processed to the weight. The final, all those weight is calculated with the weighted sum. So I can define in the form of sigma. This sigma is nothing but the weighted sum. So after calculating this weighted sum, we are passing through the some of the activation functions. So here we can define in the form of S symbols. This symbol is denoted for the activation functions. So why we are using this activation function? This activation function is mainly used to modify the weighted input. So we are passing through some of the inputs, and we are manipulate with this weight and calculating this weighted sum, and is moving to the activation functions. So this activation function is to modify the weighted input to produce the required output for this format. So these will be the inside the artificial neuron. So in this format, there will be two important notations. One should be the perception, other one should be the functions, activation functions. See, actually, what is the meaning of perceptron? The perceptron is a special case of neurons. It is based on some of the activation functions. So in this perceptrons, the general artificial neural networks, the mathematical approach is defined in the format of f of x is equal to 1 if w dot x plus b is greater than 0 or 0 otherwise. So in this mathematical format, the x will be the input vector and m is the number of the inputs to the perceptron, and b is the bias. So the main usage of bias is the bias is to shift the decision boundary away from the origin and does not depend any input value, because the input value of default, the input value of the bias is always 1. So coming back the perceptrons is containing two layers such as input layer and output layer. So based on this input layer, the input layer is used to it is a node that capture the input values, and when the format of the output layer is nothing but it is nodes that generate the output values. So these are some of the perceptrons. Coming back from this, the perceptrons, some of the uses of this perceptrons is generally used for to classify the data into the two parts. Therefore, it is often known as it is a linear binary classifier. So these are some of the format of the perceptrons. So the next one should be the feed-forward neural networks. It is another format of this version. So the feed-forward neural network is an artificial neural network. So where the information moves in only one direction, that is the forward from the input nodes through the hidden nodes, if any of the output nodes. So from this, in this format of this diagram, we can define in the form of variable 1, variable 2, variable 3, variable 4. So all those variables are transferred to the input layer. Then the input layer is passed into the hidden layer. This hidden layer is calculating some of the formats of the weight and activation functions, all of in the form of networks, and finally is produced in the required output. So an example of the feed forward neural network is the one hidden layer with the 3 neurons. So this is an example for that. So in this feed-forward neural networks, there will be two important notations. One should be in this feed-forward neural network, there are no cycles or loops in the network. Or the second one should be in the form of MLP. MLP is a multi-layer perception. The multi-layer perception is a kind of feed-forward neural network. So this network this perceptrons is comprised at least the 3 layers of nodes, as I told in the format of diagram. That is the input layer, hidden layer, and output layer. So except for the input nodes, each node is a neuron that uses a nonlinear activation functions. So this function is mainly formatted with either in the form of linear or nonlinear approach. So here the multiple layers are nonlinear activation function, which will be distinguished between the multi-layer perception from the nonlinear perceptron, because it can distinguish data that is not linearly separate for this MLP. When in the format of the hidden layer is causes the decision boundary to be in the form of the curve that separate the overlapping of the data. So in this format of the overlapping of the data, all the data will be in the form of constant values, and that the input bias is 1. So in this the feed-forward neural networks, the major questions is arising is how the big feed-forward can be. The solution should be the deep neural networks. Reason is the deep neural networks is a multiple hidden layer and input layer and output layer. So this is the format of the feed-forward neural networks. So the answer of this question is deep neural networks. Actually, what is the deep meaning of the deep learning? The process of estimating the weights and bias of the deep neural networks is called deep learning format. So these are in this slide we will discuss about some of the activation functions. So actually, what is the meaning of activation function? That activation function is defined as an output of node based on the weighted set of input. So we have for the previous diagram we can define in the format of we are passing through the input layer, and that's intermediate of input and output. We have this hidden layer. So this function is defined in the form of output node based on the weighted set of inputs. This output is then used as an input for the next node, and so on until the desired solution to the original problem is found. So the main thing of this activation function, it is a nonlinear activation function, makes neural networks, it may be the nonlinear. It causes the decision boundary to be curved instead of the straight lines. So in this format, the most common activation function is called as a logistic sigmoid and a TANF and a RELU, that is a rectified linear unit. So for this, the activation function, the sigmoid is expressed in the form of the standard deviation of x is equal to 1 divided by 1 plus e power of minus x. So we can define in the format of the constraints of this input, or the constraints in this input. It may be that they vary from this minus 1 to infinity, but the constraints output within the logistic sigmoid is 0 to 1. The next one should be the TANF. TANF is another activation functions. So this function is carried out based on the mathematical format. f of x, or we can refer as a tan h of x, is equal to e power of x minus e power of minus x divided by e power of x plus e power of minus x. So in this tablet activation functions, the constraint output within the range of -1 to +1. Next, we move on to the rectified linear unit. So this rectified linear unit, RELU, is a major part of this artificial neural networks or deep learning or machine learning, whatever may be. This unit, this function, the common activation function, it is a non-linear function, and it is not differentiable because when you substituting the x is equal to 0, when you're assigning x is equal to 0, automatically that point is consistent the origin point. There is no attainment of limiting value of to producing this output. So we can represent the mathematically where f of x is equal to 0 for x is less than 0, or if the bias value of the output value becomes 1, for the definitely the x value is greater than or equal to 0. So these are some of the format of the activation functions. So in this activation functions, we move on to the application of neural networks. We can discuss with what is in cost functions. So this cost function is a measure of the how good the neural networks did with respect to its given training sample and its expected value, and it may be depend on the variables such as weight and bias. For this activation function, it contains the multiple value, but when the cost function is a single value, not a vector, because it states how good the neural networks did as a whole. So when we represent it in the mathematics of the cost function, the function may be in the format of input or output or weights or biases. However, the weight and bias may be not always being known because the cost function its mainly focus is used for solving the optimization problem of finding the optimal weights and biases that results in the best prediction of the output. When you move on to solving the neural networks with the best prediction outcomes for the training data samples will have the minimum cost. Solving the neural networks involves finding the optimal values, optimal weights and biases using the gradient descent of the algorithm. So when this the format of the activation function and cost function, how we are able to solving the neural network problem. So the solving the neural network problem means the first one should be estimating the value of the weights of each connection between the nodes. The second one should be the estimate the value of the bias of each hidden and output values, and third one should be estimation is done using the hierarchical data of inputs and outputs. So the next part will be the applications of neural networks. So in the form of applications of neural networks in the industry 4.0 the era, it's mainly used for the speech processing, image recognition, natural language processing, and finance and banking. In the form of the speech processing, the area is mainly focused on this format is Google Assistant and Siri. It is a take action based on voice commands. When the second part of the image recognitions, so the major in the current research perception area, in the form of neural networks, the image recognition is used for the driverless cars. That cars maybe it's capture images for driving decision for this approach. Then the third one part will be the natural language processing. So this natural language processing is a main area for this artificial neural networks. In this format, the main thing is fast document retrieval and information retrieval or something. It should be in the form of grammar, lexicons, or all the things in the form of NLP. The main focusing of the research perspective is the fast document retrieval. It should be represents the documents numerically in the form of words content. And finally, it should be the finance and banking sector is also using the form of neural networks. In this era of this format, the applications of neural networks is not only for this list given below. The plenty of the applications are available. These are some of the major applications of the Industry 4.0. Thank you.